Okay, yeah, yeah, that's correct. Okay. Assistant professor, agricultural university campus.
Okay, welcome back, explorers. I'm so glad to see you are still here. Fantastic. I can assure you are in for a treat. I'm just checking if I did get my treat. I did. There was a treat outside, actually. Let's start the final session here. You are going to hear a very personal talk, a personal journey of somebody who had a dream some 20 plus years ago, and then he realized his dream very recently. And remember what I was saying at the beginning, that you can achieve what you want to achieve, but you have to give time. So let's hear from our guest speaker, who is Dr. Yanis Baziotis from the Agricultural University of Athens from Greece, and he's going to take us to Antarctica, probably the closest analog to the moon that we can reach today. Yanis.
Thank you very much for everybody being here, and also thanks a lot for the invitation from Dr. Mahesh Anand. I'll talk about two things today. First of all, my experience in Antarctica, first, and second, more importantly, the dream. When you are in Antarctica and you are thinking about this 28 years ago, because I started thinking about this at the age of 10, now I'm 38, at the age of 10, then I was waiting for 28 years to achieve my dream. But you never abandon your dream. This is my major conclusion. So the first thing is to be in Antarctica, but I have to give a special credit to my friend and colleague, Dr. Mahesh Anand, and to the Open University. Thank you very much for hosting me here. In order to achieve your dream, you have to fail. This is very important. So I went to Antarctica in the context of ANSMET mission, ANSMET from the words Antarctic Search for Meteorites. And in order to get there, you have to send letters, just an ordinary letter. I started in 2013. That's some representative stuff from my letters. I never received a message or an email or a reply from my letters, but I was keep going. I was keep insisting, sending this letter every single year. I know that the process was very competitive, and as Michael Phelps says, it's very important to continue to achieve your goals, your dreams, and this force to achieve your dream will force you to implement your dream. In 2017, I sent this letter. This letter was something strange, something different compared to the previous one. I stated that, okay, doesn't matter how long I have to wait. I'll be waiting for many years, for several years, like what is said here, because Yanis, my name, this is your dream. You have to wait a lot in order to achieve it, and when you achieve it, you will be very happy. You will be the happiest, maybe in the world or in my small world, after receiving the acceptance. Imagine that in order to be part of ANSMET, it's a very competitive process. They receive more than 200 letters every year, and only 1 or 2 persons being accepted. And of course, most of these guys are not from Greece. So in 25th of April, 2017, just a year and a half ago, I received the acceptance from the principal investigator of the project. He sent this letter on, it was Sunday, initiated his message with this. He said that, okay, before you scream and say, yes, you did it, you have to read all of these 3 pages that will follow my email. All of these pages were included the possible dangerous things in Antarctica. But they knew that when I was being accepted, they knew that I had to say yes. So I replied immediately, after 10 seconds, I replied yes to this invitation. Why the meteorites are important? Today you have already learned about meteorites. So the first thing is that these meteorites are the stuff, the rocks, the gifts from heaven. They are coming from above, from the heaven, and they help the scientists to study either the first stages, the very first stages of the evolution of our solar system by just studying the minerals. Also, they help us to study other planets like Mars by studying the minerals of Martian meteorites. Also, they help us to study the moon. So these are two representative photos of the first lunar meteorite that has been discovered in Antarctica in the context of ANSMET mission in 1981. I was just 1 year old that time. This is ANSMET, the logo of ANSMET, Antarctic Search for Meteorites, and 23,000 meteorites have been recovered since the beginning, since 1976. That means 40% of meteorites that have been recovered from all over the world is from ANSMET, from Antarctica. It's a NASA-funded mission, and the question is, why in Antarctica? We are going to Antarctica because there's a natural process of meteorite accumulation. In Antarctica, we have the so-called katabatic winds. They are really strong southern winds, very strong, more than 15 to 16 Beaufort sometimes. And if you have a meteorite that fell on the ice several thousand or even 100,000 years ago, before present, and you know that the ice is moving from the east to west of Antarctica. That means if there is an obstacle in the Antarctica, and the obstacle for our case is the Transantarctic Mountains that cross-cut the continent into two separate parts, the eastern and western. So the ice flows from eastern to west, but stops at the base of these mountains, of the Transantarctic Mountains. So whatever is hidden inside the ice, whatever is inside the ice is uncovered by the erosion of the ice. So the ice is ablated very fast, and everything that is included there is just rested at the surface. Then we are going to the eastern part of Transantarctic Mountains searching for meteorites. For this season, we stayed there for around 80 days, but in the deep field, we remained for 5 weeks, stayed in scout tents. I'll show you later what I mean. This is where all begins for me. So this is the blog of the mission, caslabs.ks.edu/ANSMET. It's the mission where you can find all the news of every single mission the last at least 5 or 6 years. Even this mission, the current one, they are already in Antarctica, and they post at least 1 or 2 photos every single day with a short text. This is my path. It started from Athens, then I moved to Munich in Germany. Then I flew with ordinary flight from Germany to Western United States in San Francisco. And then we crossed the second ocean after Atlantic, the Pacific. We moved using, again, ordinary flights to the North Island of New Zealand, to the place called Auckland. And afterwards, we flew to Christchurch, where we got all the necessary equipment and traveled from Christchurch to Antarctica by military flights. The total distance is 26,000 kilometers, and if you compare it with Earth-Moon distance, it's 1/15. So Moon, after all, it's not so far. It's just a 1/15 distance of Earth-Moon. When we land to Antarctica, the first stop is at McMurdo Station. The distance of McMurdo Station and South Pole is 1,600 kilometers. And if you are not so familiar with these distances, then this is just an outline of UK. The distance between south and north is roughly 1,000 kilometers. So the whole UK is a bit smaller compared to the distance between McMurdo and South Pole. When we arrived in Antarctica, we had to spend around 7 to 10 days for training. Then we learned how to use our ski-doos, snowmobiles. These are our tools to walk on the ice. Also, we learned how to set up a Scott tent. This is a very basic setup of a camp in Antarctica, composed by several Scott tents. These tents have a double insulated walls. They have dimension 2.7 times 2.7 meters, and the height is around 2.3 to 2.4 meters. This is a nice photo, an overview of all of our members of the team. Imagine that there are two guys here, John and Brian, who are the leaders in terms of safety. They are mountaineers. There's also a PI, the principal investigator of this team, Jim Kerner, and also the rest of the members are volunteers, as me. I was volunteer on this team, 8 persons in Antarctica. Then we split it into 2 teams composed by 4 persons each. We moved from McMurdo Station to the Shackleton Glacier Camp. That's an intermediate stop. So we moved from 0 altitude to 1200 in order to adjust to the changes of the altitude. This is the equipment of our team. 5 tons was the weight. And we've been there using LC-130, the military plane. From there, we moved to the deep field of Antarctica, just the final obstacle before the South Pole, around 200 kilometers from the South Pole, by twin otters. The twin otters are small planes, able to carry only 1 snowmobile, just a couple of persons, and some stuff of equipment. This is the process of entering this ski-doo or snowmobile into the twin otter. A small plane, you see that it's not easy to move this snowmobile into the twin otter. You will see why. The weight is 350 to 400 kilos. It's a difficult process. You see that overall it requires at least 4 persons, a driver and 3 more. But these guys helped us from Shackleton Glacier Camp. When we are at the deep field, we do this whole work alone, just 4 of us. Then this is how you look like when you are outside of your tent in just the first minute. It's really cold. The average temperature was in the range of -30, -35 centigrade, with a wind chill down to -45 to -50 centigrade. In the field, we were driving our ski-doos, wearing 5 layers at the upper part of our bodies, 3 layers at the bottom, very special boots, 2 pairs of socks, 2 pairs of gloves, and several other things like our goggles, which are very important in order to protect from the UVA, UVB radiation in Antarctica. This is one of my favorite photos because we are in Amundsen Glacier. The ice is rested at 2.5 kilometers, while the top of the mountain, Mount Christensen, is at 3,640 meters. The distance, the horizontal distance from me to the mountain is only 8 kilometers. There's no other reference point, so it's not easy to understand how far is this place. And here, it's the 4 of us. It's very important that we are human. We have feelings. That's why we called Santa James in order to celebrate the Christmas period. It's the Christmas day right now. And also a very important photo for me and also for the rest of the guys, except this. This is the leader of our team. He's been in Antarctica since 1980, 38 consecutive years. But this is the first meteorite that we discovered in the deep field of Antarctica. The results, we have found 263 meteorites. some representative images from these meteorites. Most of them belong to the chondrite type, which is the most common meteorite found globally on Earth. 86% of meteorites belong to this type of meteorites. And this is how it's looked like a normal day in the field. This is a video. I'm just driving my Ski-Doo. I have a GoPro on my head, camera. John is there, the leader. I'm driving, standing as it is, as like now. I'm standing there on my Ski-Doo, driving. You are not allowed to sit because the problem is that if you're sitting on your seat, then it's not possible to turn your head right or left. You don't have any freedom in your body to search nearby. That's why you're standing there, working from 9 o'clock in the morning until 5 to 6 o'clock in the afternoon, with just one stop for lunch around 1 o'clock, 1 p.m. And covering all the distance, all the areas of ice in transects. So we had a GPS. We knew every time our position and all the path that we have followed the previous days or even weeks. This is how it looks like inside the tent. It's very nice, this thermometer. It shows you that the temperature is 33 degrees, but at the top of your tent, because at the bottom, the temperature was around 0 degrees Celsius. So there was a huge thermal gradient inside the tent when the stove, I'll show you later, a stove that operated with propane was working. At the end of the day, when we are going to sleep and turning off our stove, the temperature inside the tent was homogenized very rapidly in 5 or 10 minutes at 0 plus minus something degrees Celsius. And of course, you should receive at least 6,000 to 7,000 calories per single day. That's why you have to cook, and in order to cook, you have to have a really good cooker, because these are really one of the worst potatoes ever made by me. But the other guy was working, my tent mate was cooking actually really great. He has the experience. The difficulties are, one of the major difficulties is the crevasses, the cracks on the ice. Sometimes they are really deep, more than 10, 15, 20 meters, and really wide, more than 1, 2, 3 meters long. That's a major difficulty for us because we are working continuously without stop on the ice, driving our Ski-Doos. Sometimes all of these cracks are covered by snow, soft or hard, so you should be very cautious. The other potential danger is inside the tent, because this thing uses propane, and it emits CO, carbon oxide, which is a gas that could be very toxic and harmful for the human being. We faced also some other difficulties, the weather. The wind chill here is minus 45 to minus 50 centigrade. We remain in this particular area for 5 days inside our tent. And as Stan Love, one of the astronauts of ANSMET 5 years ago, he said that being in Antarctica is more or less the same thing like being on space. You will die if you don't wear the necessary equipment. So I'm here, that's why I was wearing the necessary equipment. We're alive, and our mission was successful. The first thing is to bring back all the people safe back to their countries. As Dr. Mahesh Anand said, you should follow your dream. This is one of my motto. I started at the age of 10, 1990. Imagine that I want to go to Antarctica. This is where I did this thought at the yard of my grandmother. So this is for my case where everything begins. I wanted to go to Antarctica, but in order to get there, you have to have also some really great sources of inspiration. For me, the first source of inspiration, the first person who inspired me to work with meteorites was Larry Taylor, one of the most important guys in planetary science. He started his career in planetary stuff at the end of 1972, 1973, just after the Apollo missions. So the guy at the center is Jack Schmitt. Probably you heard about this guy an hour ago. He was the only geologist that walked on the moon. Just 40, almost 46 years from now, on 7th December 1972, Apollo 17 has launched from United States. So those two guys are a constant source of inspiration for me. What I really like to show, especially to the young children, to the students, is that you have, in order to follow your dream, you have to start from the word love. You have to love it. You have to be passionate for this. If you love something, for me, geology is something really important. It was my dream. Then you have to split your dream to small goals. If you follow all of these goals, then you should be very dedicated, and you should pray also for the obstacles. All the obstacles or every next obstacle will make you better, make you stronger in order to overcome the next obstacles and so on. After this, you will be ready to succeed. So the implementation of each separate goal will lead you to the dream, and for my case, to the happiness. If you have all of these things, all of these previous things, it's like a balance, but there's no balance in your life. So you have to have your family, your friends, your wife, your kids, or whatever brings you the balance in your life. For me, the take-home message is that you should follow your dream. No matter where you come from, either from Greece, which is a poor country, at least it's not so well related with planetary science, just follow your dream. If there are obstacles, never abandon your dream. I will let you with what Steve Jobs said about the vision. The vision will pull inside it, because this is the very important message for us, the outcome. If you really want something desperately, if this is the dream of your life, this will be your vision, and this will pull you. This will pull in its direction. Thank you very much for your attention. Just a comparison between the Stasio Tranquillitatis, which was the first base that the Apollo guys named it as the base of silence. I have also my silent base in Antarctica. If there's no wind there, if there are no cars, of course, there are no plants, there are no birds, nothing, then it's very possible to hear the sound of silence. Thank you very much, again.
Well, everybody, wasn't it worth staying? Yes, yes. Thank you very much, Yannis. I know it is getting close to 8 o'clock, but as I said early on, that we can go in 10, 15 minutes extra, and I'm sure you wouldn't mind another 10, 15 minutes, would you? Because you will get a chance to ask questions, right? So what we are going to do now is to give you an opportunity to ask any questions that you may have to Yannis, and we'll spend 5, 7 minutes on that. And then afterwards, I will have another special guest for you to give a very short speech that I'm sure you will find it very motivational. So stick around, and don't forget that we will finish the event with another live performance by Yaz, who is waiting for us. So let's get started with some questions.
I have a question, actually.
Okay.
After my talk, who wants to be in Antarctica? 1, 2, 3, 4, 5, 6, 7, okay, 10, 15, okay, 15, okay, that's good.
So 1 or 2 from 200, so how many years it will take for them?
Yeah, you need around 5 years in order to get there. On the average, maybe 3, 4, 5 years. So do it.
Good. Okay. Let's take some questions. So we have two people moving around with mics. So if you raise your hand, then somebody will get to you. There is one at the back, please.
Thank you. Yannis, thank you for your talk. That was very interesting. When you were driving on the skidoos, you were passing lots of rocks. You weren't stopping to look at them.
Okay.
So presumably not every rock there is a meteorite.
Mm-hmm. Okay. First of all, we are searching for hours and hours, days and days, weeks and weeks. We spend around 5 weeks on searching. When you are on skidoo, you're driving at very low speed, 5 to 7 kilometers per hour, very slow. If you found a rock that is candidate for meteorite, then you just stop and inspecting very closely this particular rock. So you do the same process hundreds or even thousands of times per day. Drive, see something interesting, stop, inspecting, and then again and again. It's the same process. So in the video that I showed you before, searching for meteorites, all of these rocks were terrestrial. None of these rocks were meteorite. Of course, 40% of meteorites have been discovered in Antarctica overall, but we search for 1,000 meteorites or even hundreds of thousands of meteorites every season in order to find, in average, 400 to 500 meteorites in every season.
Good, thank you. Another question? Yes, right in the front.
Did you see any animals or anything unusual in Antarctica?
You mean animals? Yes. Actually, the only animals that we faced were near McMurdo Station. There were only 3 penguins because the major population is at Cape Reynolds, 50 kilometers away, and also some seals, skua, they're birds, and that's all, nothing else. When we be in the field, in the deep field, there are no animals, nothing, not even bacteria. The temperatures are really low, so it's impossible to resist there.
Oh, there's another question right in the front. Just wait for the mic.
How long did you stay there?
Overall, we stayed roughly 80 days in Antarctica, but in the field, we spent around 5 weeks inside the tent, the Scott tent. I know that you will be the next explorer after 10 or 15 years. I can see it in your eyes.
Yeah, great. I think that I can see two hands raised there. Can somebody reach there?
Do you fall into holes?
Again?
Did you fall in the hole?
Oh, okay. This season we were lucky. None of us has experienced this kind of actually nobody has fallen in on the ice or nothing, or on a hole, nothing. But you should be lucky as well. So
Okay.
the answer is no.
Right, good. It's good for health and safety.
You should be very cautious, but lucky at the same time.
Right, is there any question? No? I can't see.
There's a
Yes,
question
okay,
here.
there is one.
Yannis, thank you for the presentation. Now you've realized that dream, what's your dream now?
Okay. I said that before, I think, to another colleague. Actually, the first dream was to be in Antarctica. The second dream was to find a Martian meteorite in Antarctica. I didn't. So maybe that answers you. It's very possible to, hopefully they will accept it, but I will try to reapply again.
Hopefully you won't have to wait 5 years now.
Yeah,
You will be actually sought after.
I can
sure.
wait.
Right, good.
You should be
Any-
very patient.
Patient.
Patient. In every dream, you should give the right time in order to achieve it. So the Martian meteorite is very important. Only roughly 200 meteorites have been recovered worldwide. 200 out of 60,000 meteorites. So it's not common to find a Martian meteorite, especially, of course, in Antarctica. That's why I can wait.
I think we have got a question there from a young person there. Okay, go
Is
on.
there any different types of meteorites?
Yeah, we have recovered ordinary chondrites, which is the most common meteorite. Also, we have recovered iron meteorites from Vesta, the asteroid Vesta, which is between Mars and Jupiter, and also carbonaceous chondrites, CM2 type. So we had collected a variety of meteorites this season.
Right. Okay, I think we have final.
But no
two-
Martian.
No Martian. Final 2 questions. I think there is one
There's
here.
one more here.
And I think there was there one question? No. Okay, let's get on with this one.
Wouldn't it take much longer to go like slower at 5 or 10 miles per hour? But then if you went faster, wouldn't it take less time to cover more ground in the field?
The problem is to be efficient. That's why we are covering all of these distances very slowly to be as much efficient as we can in order to start, stop, always. If you are really fast, if you drive very fast, it's not possible to see all of the rocks that are just around you. Sometimes, and this is something important, the average size of the meteorites that we recovered, it's around 6 to 7 centimeters. So they start from 2.5 or 2 centimeters, which is really small one. That's why you should be very careful. If you drive fast, probably you will miss them.
Okay, I think it's about time we thank Yanis once more.
There's one more question, I think.
Is there
No?
one more?
Is it a question? Okay.
No, he's thinking. He's thinking. Great. I think we should thank Yanis once more. Thank you very much.
Okay.
If you think about any other question, Yanis is still here, so before you go home, you can catch him before we go out for dinner afterwards. But I just wanted to say that those people who have joined us online obviously are not able to ask questions, but I'm sure that they will find ways of communicating with us, and we will try to answer their questions afterwards.
Of
So
course.
Yanis, thank you once again.
Thank you very much.
Let's move on.
Okay.
So next, I would like to introduce to you and invite to you my esteemed colleague, Professor Monica Grady, to give a short speech about her own impression about this event and why we should be doing space exploration. And I don't think she needs any introduction, but I must give some introduction in my own context. You saw Professor Larry Taylor's picture there. He was the one who actually pulled me from the UK. I did my PhD here, and Larry then called me and said, okay, I have a job, come and work on moon rocks and diamonds, and I couldn't say no. But then when I was working with Larry, the person who actually pulled me back to the UK was no other than Monica, right? And I couldn't say no to Monica. So without further ado, Monica, please.
Thanks very much, Mahesh. I've got 2 tasks now. First of all, I've got the colouring competition judge to announce the winners. And I think there are, how many? 5 of them. And they're all here. And they're brilliant. They're all very different. So the prize, I think, you have the prizes. You have to come and see this lady here for your prizes. And the prizes go, first of all, to Emily Crawford from Buckingham School. Is Emily here? Oh, Emily's down there. Well done, Emily. So here, we've got this one here. It says, I think we should go home. And it's from Casaneva Roos. Is that right? Casaneva Roos from St. Paul's. Oh, Cassandra Roos. Sorry, Cassandra. So congratulations to Cassandra. I've got a great one here of a lunar base, which is from Toby Crawford. Toby here? Or is Toby gone? Oh, Toby's over there. Excellent. Well done, Toby. And, this one's lovely with crayons. And this is from Finton Is Fintan here? Well done, Fintan. Good one for you. And we've got another one. Oh, this one opens up. Wow. Oh, that's the Earth and the Moon and a rocket. And that's from Oscar, who's 10. Is Oscar here? Oscar's just outside. Oh, well done to Oscar. Okay. So that's great. So if you can all, at the end when we finished, after the music, because we're going to hear Yaz play her composition again, which will be fantastic. Now, there is, it's been an amazing evening. I hope you've all enjoyed it. I hope you've had chance to write something on the moon wall. I hope you've had chance to put your feet in that kinetic sand stuff. I had to go at that, and I'm wearing high heels, and it's like, ooh, yeah, that's a bit different, isn't it? I hope you've had a chance to look at the meteorites. How many of you touched the meteorite tonight? Lots of you. And what did they tell you? Did they say to you, you're touching something that's older than you'll ever touch, ever? Something that's 4,567 million years old. Just imagine. And can you imagine going to Antarctica and collecting a meteorite like that? Now, when you're in Antarctica, you're not actually allowed to touch the meteorites, because one of the great things about Antarctica is it's clean. And when you pick the meteorites up, you pick them up with a great big pair of tongs and you put them in a bag. And it's actually the curators back in Houston, in Texas, where these meteorites go to, who break them open to look. But can you imagine taking a rock? Just imagine. Here, I've got this. It's the thing, but it's a rock. Just imagine it's a rock. It's a meteorite, and you break it open, and you're the only person to look at something which formed 4,567 million years ago. And you're the first person to see that. You're the first person to look at those grains inside there. And that's what it's like to be an explorer. That's what it's like to really see and reach out to things that have never been seen or done before. That's what astronauts do. It's what scientists do. It's what engineers do. I'd like to think that we did this every day on a daily basis. Unfortunately, we don't. We do lots of form filling in and admin and stuff like that. But when you get back into the lab, it's fantastic. And some of the stuff that we do here, building instruments which are going to go to the moon, stuff that's been to a comet, we're going to get all those results back, and we're going to learn more about how our planetary system formed. How did planets around other stars form? And eventually, we're going to go there. We're going to walk on the moon again. And eventually, there will be astronauts wearing high heels. I put money on it. Eventually, there will be astronauts, perhaps in high heels, I hope so, or maybe flat, because my feet are killing me at the moment. But there will be astronauts walking on Mars. And maybe there are some people in this room who will be part of those teams. Maybe you'll go to Antarctica to collect meteorites, to explore there. Maybe you'll be accepted to become astronauts and be part of the cohort of European astronauts. Go to the space station, go to Mars, go to the moon. And whatever you do, though, even if you aren't the astronaut, you might be the person who is designing the astronauts' space gear so that they can actually move around. You might be the person who is deciding what the astronaut is going to eat because they've got to have the balanced diet. You might be the person deciding what sort of haircut the astronaut has. Now, you might think that's daft, but think how closely the helmet has to fit. And as technologies change, if you actually look at their astronauts, their hairstyles have changed. So there's all sorts of things. You might be designing thermal insulation. You might be doing all sorts of things, because there might be one astronaut, but there's a team of 1,000 people behind her Notice what I said, a team of 1,000 people behind her. Because there are now lots of female astronauts as well as male astronauts, because it's a job, it's a career that's open to us all. And I hope that eventually, and I'm talking now to the younger people in the audience, that when you grow up and you follow your dream, you trace it back and you think, actually, my dream began that night in the lecture theatre in the Open University, when I heard all about the moon, I heard all about Antarctica, and I heard some wonderful music. And it all came together, and I realised that that's what I wanted to do. So I just want to thank you all very much for coming here tonight, for finding out about what we do. Please feel free to follow us on Twitter. There were plenty of things about Twitter handles and whatnot. Please take back with you the memories that you've created tonight, the pictures that you've drawn, the thoughts of what you've written on the moon wall. Come again next year when we'll have some more exciting things to share with you. But I'd just like to say thank you. Thank you very much to Mahesh and his team for organising this. And I'll just finish by inviting Yaz to come back onto the stage, and we'll do another performance of her beautiful work. Thank you very much. Thank you, Yaz.
Thank you very much. Wow, wasn't that great? Now, I think we will very soon finish the event, but as I said earlier to you, I would forget, but I have not forgotten.